Hello students and welcome to another video. I'm your teacher Mr. Flynn, and today we're going to be talking about voltaic cells. Now if you haven't watched my previous video on redox reactions, please go watch that first. This video will be very confusing if you have not watched the video on redox reactions, because I'm going to throw those terms around and you need to understand what they mean. Okay? Now when we have oxidation and reduction occurring, okay, that's basically describing the exchange of electrons. And when electrons are being exchanged, we call that electricity, essentially, okay? Like electricity is flowing through these wires and they're powering the lights in my classroom, okay? And if I break that connection, well, the lights will turn off. And if I reconnect them, the lights will turn on. And basically, electrons are flowing through that wire and doing work. All right, we're using those electrons to do work. And we can harness that by creating a battery. Now, a battery essentially is a voltaic cell. All right, and we're going to create batteries. And how we do it is we use metals. So different metals, when they interact with each other, will exchange electrons. And a very common one that we will be working with today is used with pennies. So pennies are made of zinc and copper. So copper pennies, like solid copper pennies, are very expensive because copper is expensive, okay? And we have substituted copper for zinc. And so the inside of the penny is zinc, and the shell of the penny is made of copper, all right, to help offset the cost. But zinc and copper like to exchange electrons, and we can actually create little piles of pennies that have actually had the copper removed, and so the zinc and the copper are interacting with each other. You can actually cause a current to flow, and we can actually build a little battery with pennies, okay? And what we're going to do is show you what's happening in between them and how we can go about building this battery, okay? But basically, the idea of an electrochemical process is taking the chemical potential energy of an electron flowing and turning into electrical energy, okay? And electrical energy could be used to do work, like power a light bulb, turn on a fan, etc., okay? Now, the rest of this we're going to get into, but the big piece here I need you to recognize is anodes and cathodes. You've probably heard of those terms before because they're on batteries, right? You have a red end or a black end or a plus end or a minus end, and that represents where the electrons are leaving and where they're coming and going and the place where they're landing and getting to. All right, so we have an anode, which is the end that's being oxidized, and the cathode is being reduced. So the anode is losing electrons, and the cathode is gaining electrons. And that's what we're recognizing between anodes and cathodes, okay? All right, and to keep the reaction going, we actually have a salt bridge that keeps everything neutral. Okay, there's the word I'm looking for, neutral. All right, so let's just kind of show you what this looks like down below. Before I get into the image, I want to show you this equation. So we have zinc and we have copper. Now, if you remember our oxidation numbers, numbers that are by themselves are 0. So zinc is 0 and copper is 0. Now, copper in this situation is going to be plus 2, so it has a charge. So it has an oxidation number of plus 2. Okay, and this one, zinc, loses electrons, and it's going to be also plus 2. So if we look here, zinc goes from being 0 to plus 2. And that means it lost 2 electrons, so it was oxidized. So zinc is losing electrons. Copper, on the other hand, goes from being positive to neutral, so meaning it gained electrons. So copper wants to steal electrons from zinc. And we're doing that with these oxidation numbers I've listed out above. All right, so we're recognizing where the oxidation is happening and where the reduction is happening. So you'd expect that the anode is going to be zinc and the cathode is going to be copper. All right, so let's show you what this looks like down below. All right, now there's a lot going on in this image, but I'm going to kind of break it down for you, okay? I'm going to use a different color because red's everywhere. Okay, right here we have a zinc plate and we have a copper plate. And the zinc and copper are connected by a wire. Okay, now the electrons, they can move through the wire. So when we connect them, okay, zinc is going to start losing electrons. Specifically, it's going to lose 2 electrons, and it's going to be given to the copper. Now, here's the issue that we're going to face here, is as zinc loses electrons, it becomes an ion. Okay, it becomes positive 2. And when metals are ions, they will become part of a solution. So this solution is going to become increasingly positive. It's going to be it's losing, let me back up, my bad. Let me exchange this. Okay, it's going to be gaining more and more positivity. Zinc +2, meaning it's losing electrons, it's lost electrons. So that means it's going to become increasingly missing electrons. So it needs actually, yeah, I was right. Never mind. I'm confusing myself. I'm trying to explain this, and I'm connecting thoughts in real time. All right, so right here, it's going to become increasingly more positive because it's losing electrons, and we need to balance this out. We have an off balance because in our solution here, we're going to be having these zinc ions in solution. So this plate is slowly going to disappear. It's going to disappear, and the zinc is going to become part of solution. You may ask, well, why is it becoming part of the solution? Because it's charged. Water really wants to interact with charged ions. And so zinc is going to just dissolve into the water, into the solution, and it's going to lose those electrons. And then on the opposite side, copper, okay, from the solution, okay, we have a copper solution, it's going to accept those electrons, and this copper plate is actually going to get bigger and bigger. The copper plate's going to increase because the copper from the solution is going to attach to those electrons, and it's going to become neutral. And when it's neutral, it just becomes part of the plate. So one side, zinc is getting smaller, and on the other side, the copper is getting bigger, right? And so we're working with a copper solution and a zinc solution, respectively, for each one, okay? So the copper, and you may say, well, where'd the copper come from? Well, the copper's in the solution. All right, for this reaction to occur, the copper is in solution and it's falling out. And it's going and attaching itself to the plate because it needs to accept those electrons. Those electrons need to go somewhere. And that copper is willing to take those too. All right, and then now that we're losing our positivity, this one's becoming more negative. And eventually, our reaction is going to stop because we're going to have too much negative and positive, and we need to balance those out. All right? And so what we need to do is have something called a salt bridge. So the salt bridge has potassium sulfate in it. Now the SO4 is -2, and this -2 is going to interact with this zinc, all right, and it's going to neutralize it. So now we have some negativity to counteract our positivity that we're forming. So now it's neutral again. And then this potassium that's positive is going to interact with this negativity, and it's going to make it more neutral. So we're trying to balance out these charges. So as we give and take on one end, we have to give and take on the other end. So if we're giving electrons from zinc, let me use a different color, from zinc to copper, we also need to go back and make sure that those charges get balanced. And that's the purpose of the salt bridge. And so when we stack our pennies, what we're going to do is we're going to use a salt solution, and we're going to make little pieces of paper, and we're going to stack them in between our little pennies, and that way it will create a little salt bridge for us so we can neutralize the reaction as it happens. Okay? Now, the big idea here is we have these half cells, which basically represent what's going on in each half of the reaction. Okay, so the zinc is being oxidized, and this is our negative end, called our anode. And then the cathode is gaining electrons, and so it's becoming positive, all right? And it's being reduced. And we've talked about this up above, all right? And so the idea with this interaction is that zinc wants to give electrons to copper, and copper is happy to take them from it. And they're exchanging electrons. And we're utilizing this chemical process to basically produce electricity through a wire. And the salt bridge is there to neutralize the reaction. Okay? Now, this could take some time to grasp. You could even see me, like I was tripping myself up a little bit as I was going. And, you know, and I've taught this many times. It's been a while since I've taught this, right? But the idea is we recognize the players. We have zinc and copper. One is giving, one's taking, and then a salt bridge is there to neutralize. Okay? And the anode is the one that's being oxidized in that it is losing electrons, while reduction is gaining electrons. Okay? All right, so hopefully I've illustrated this enough for you to kind of build some foundational understanding. Just realize we're only doing this for a day. We're not going into like the deeper science of these different metals and such. That's for much later chemistry if you're interested. But we want to get the idea, the basics of a battery. Okay? Thanks again for watching. Till next time.